Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to have x minus 9 times x plus 7. For the math knowledge question, we have a smaller triangle and we have a bigger triangle. And it says one pair of corresponding sides of your two triangles are 3 and 8. And then the perimeter of this triangle is 12. We want to know what is the perimeter of this big triangle. Well, the perimeter is the same thing as, is going to be in the same ratio as the side lengths. So we can set up a ratio of those side lengths, which would be 3 over 8. And then we can set up a ratio of the perimeters. So 12 over, we don't know the other perimeter. So you can cross multiply here. 3p equals 96. And then divide by 3. And that gives you 32 for your perimeter. Okay, so now we're going to look at lesson 18, sums, differences, products, and quotients of functions, and then the composition of functions. This should be reviewed from pre-calculus, maybe algebra 2, but definitely from pre-calculus. So hopefully this won't be a terribly difficult lesson for y'all to understand. So we have two functions. We want to find the part A, B, C, and D, and then also the domain of each. When it says f plus g, our f function is x squared, our g function is square root of x. So that is x squared plus square root of x. You can't combine those, so you can leave it just like that. We're going to come back and do the domains in a minute. For this one, f minus g, f is x squared, g is, again, square root of x, so x squared minus square root of x. That's all you can do for that one. For this next one, we would have x squared times the square root of x, which is the same thing as x squared times x to the 1/2, because you can write the square root of x as x to the 1/2. And then you can add these two, so 2 and 1/2 is going to be 5/2. And so that would be your answer for part C. For part D, we would have x squared over the square root of x, which we can write the square root of x as x to the 1/2, and then we would subtract these because we're dividing. And so 2 minus 1/2 is 3/2. Now for the domains. For part A and B, they're going to be the same domain because we have an x squared, any number can be plugged in here, and we have a radical. What kinds of numbers can we plug into our radical? The domain, x is in the reals, x is a subset of the reals, such that our x value has to be greater than or equal to 0, because you can't plug in negative numbers into your radical. So that would be for this one and for this one. For this one here, we have to look back at the original one. So we can plug any number in here, but again here we can't plug in negative numbers. So the domain would be again the same one. So all three of these have the same domain so far, because we can plug in any number as long as it's positive into the radical. However, this one is going to be a little bit different, and it's different because our radical is on the denominator side. So we cannot plug in 0 into our denominator. So it wouldn't be or equal to 0 over here. Your domain would be x is in the reals such that x is just greater than 0. Because you can plug in positive numbers, you just can't plug in 0 here. So that would be sums, difference, products, quotients of functions. Looking at composition, f of g is how you read that. And basically, you can rewrite it as f of g of x, like that. You're going to put this function g into your f function. And then you just simplify it. So we're going to write the composition of f of g of x. So I always like to take this and make it into f of g of x. And so g of x needs to go inside of f. So g of x is 3x plus 5. So instead of x, I'm going to put 3x plus 5. And then squared plus 2. And then we want to simplify. So we're going to have 9x squared plus 15x plus 15x plus 25, and then plus 2, which you can combine some like terms. And so that would be your composite function. For the domain, do we have any numbers that we cannot plug into any of this? No. So your domain is simply all real numbers. So that's how you can do composites. Looking at another one, now we want to find g of f of x. So this time we're going to do g of f of x. So we're going to be putting f into g. So instead of x, we need to put our f function. And our f function was x squared plus 2. So that's going to simplify to be 3x squared plus 6 plus 5. So that's going to be 3x squared plus 11. So that would be your answer for that one. Okay, now we're going to look at this one. It wants us to find f of g of x. So f of g of x, we're going to plug g into f. So f says 2 plus sine of x. So instead of x, we're going to put x minus pi over 2. And so that's your composite function. And it wants us to find the domain and the range. So our domain is x is in the reals. And is there any number that we cannot plug in here? You can always plug a number into sine. It may give you some random decimal, but that's okay. So you can write it like that, or you can just say reals. Either one. For your range, this sign is always going to fluctuate between +1 and -1. Remember, it goes up and down and up and down and up and down. Okay, so if this is +1, 2 plus 1 is 3. So the most that it would be is 3. And if this is -1, 2 plus -1 is 1. So our y value is in the reals such that it goes in between 1 and 3. And that would be your range. Okay, looking at another example. This is a composite function. It says use 2 function machines. I'm not going to use function machines. We're just going to make 2 functions. So some of y'all did really well with these last year in pre-calculus. Some of y'all hated them, but you eventually got it. And then some of y'all probably never got it. And that's okay. But hopefully this year you'll get it. We want to make 2 functions for this one. So we need f of x, and we need g of x. So if our f of x is just e of x, e to the x, our g of x could be -2x plus 1. And if you did f of g of x, you would plug this into your exponent, and that would give you your composite function. So that would be your answer. There are other ways to do it. However, you want to be careful that you're not just saying one of them is x and one of them is e to the negative 2x plus 1. If you just say one of your functions is x, it's probably not going to work. So that would be one possible acceptable composite function for that one. We're going to look at another one. That is a composite function, and we want to make two functions. So what could our f be, and what could our g be? So if y'all want to pause the video to think about it a little bit, y'all can. So I'm going to let my sine of x be my f function, and then if I have just sine of x, x became 2x plus 3, so that would have to be my g function. So that would work for that one. Okay, for this one, we want to find the domain and range of f of g of x and the domain and range of g of f of x. So the first thing we have to do is find f of g of x. So f of g of x. We're going to plug g into x. So it's going to be the square root of 2x plus 3. And then for g of f of x, we would do 2 square root of x plus 3. Okay, so for the domain of this one, 2x plus 3 is always going to have to be a positive number, or 0. So greater than or equal to 0. So 2x has to be greater than or equal to negative 3. So x would have to be greater than or equal to negative 3 over 2. So your domain is x is in the reals, such that x is greater than or equal to negative 3 halves. For your range, when you plug in a number here, it's always going to give you 0 or a positive number. So your range would just be y is in the reals, such that it's positive. So greater than or equal to 0. Because you could also get 0 here. Now for this one, our domain, we need this to be 0 or bigger. So the only restriction would need to be x is greater than or equal to 0. For the range, the smallest thing this can be is 0. And so 2 times 0, this would be 0 plus 3, which would be 3. If I plug in any bigger number, this is going to be bigger than 0 plus 3. It's always going to be bigger than 3. So our range would be y is in the reals, such that y is greater than or equal to 3. So that would be your domain and range for those. So you just have to think about them a little bit to get your domain and range, and just kind of plug in some numbers to get an idea as to what answers you'll have. Looking at one last one, it says determine whether the following statement is true or false and explain why. If f of x is x squared and g of x is x squared, it says the domains of f and g, f composed with g and g composed with f, are equal. So let's first figure out what f of g of x is. F of g of x would be the square root of x squared, because you plug this one into x squared. And then g of f of x would be x squared and then the square root of that. So if you simplified the square root of x squared, you get x, and then the square root of x squared is also x. So you would think that the domains would be equal. While these are the same, that is not where we look for our domain. We have to look back here. And so we can plug any number in here because it's going to get squared, and so it'll always be positive before we take the square root. But on this first one, we can't plug in a negative number here and take the square root of it. So the domain of this one, x is in the reals, such that x has to be greater than or equal to 0. But on this one, the domain is just all reals. So that is why the domains are not equal. So your homework for tonight, you do get to omit number 9. It's dealing with function machines, so you can omit that one. Make sure you do the rest of them tonight for homework, and then we can go over any questions you have tomorrow.